Okay. So, 4-6. Look at the rest of the filled-in note. Build in. No, it's okay. I can slow down, right? Okay. Look at the rest of the filled-in notes. And the most important thing in 4-6 is know how to graph or graphing tangent of, 3 tangent of 2x minus pi over 2. Be able to do something like that. And we're graphing cotangent. So I'm going to talk about cotangent in a minute. So let's just graph plain old cotangent. A complete cycle of cotangent happens. Cotangent is cosine theta. Over sine theta. Okay? And so, if we were going to do that, a complete cycle of period of cotangent happens between 0 and pi. 0 and pi. And so this is why on your test you should be just sketching little pictures or little pictures like this. You don't need the whole unit circle. All you need to know, that this is 1, 0. This is square root of 2 over 2, square root of 2 over 2. And this is 0, 1. This is negative square root of 2 over 2, square root of 2 over 2. And this point is negative 1, 0. So, if you're going to graph this plain old cotangent theta, we'll have x. This is, these are the 5 t points. We'll have x equals 0, pi over 4, pi over 2. Pi over 4 and pi. This is y equals cotangent x. So cotangent, remember we've got cosine, sine. Got on the unit circle, we've got the x coordinate is cosine and the y coordinate is sine. So at 0, you got to put x over y, so 1 over 0. That's undefined. So that's at 0 we have a vertical asymptote. At x equals 0. At pi over 4, we've got, they're the same. So you put square root of 2 over 2 over square root of 2 over 2. Sorry, anything over itself is 1. You get 1 there. At pi over 2, you're putting x over y, that's 0 over 1 is 1. That's an x-intercept.
0 over 1, 0.
It's what? Oh. What? Did I do this wrong? No. What'd you ask?
Isn't 0 over 1, 0?
See, sorry. Yes. Okay. Thank you. All right. I think I'm trying to rush. So slow down. The teacher's like, gotta slow down. Okay. And then that's 0. That's the x-intercept is pi over 2, 0. We're going to graph it. 3 pi over 4 is here. So that's going to be, we're going to get minus 1 when we put those over each other. Minus 1. Okay, and then at pi, you've got cosine, you got negative 1 over 0 is undefined. So that's a vertical asymptote at x equals pi. So if you're graphing this, so at 0, and then we've got pi over 4, pi over 2, 3 pi over 4, and pi. This is one period. The period of sine and the period of tangent and cotangent. The period of tangent x and cotangent x equals pi. Okay? So, this is a vertical asymptote. At pi over 4, we're up at 1. At pi over 2, that's an x-intercept. And then we're down at negative 1. 3 pi over 4, and then this is a vertical asymptote at x equals pi. So we got VAs at x equals 0 and x equals pi, and to graph one of these, so it goes like this. This is the cotangent function. Okay? So, but, so you're not going to go through this whole process every time. You're going to follow the instructions that were the same for tangent. Is if y equals a cotangent of bx minus c, you find your consecutive VAs, vertical asymptotes, by taking bx minus c is less than pi is less than 0. So you'll find your two consecutive vertical asymptotes. You solve that for x. The numbers you get when you solve for x, I mean, I could do it. You add the c. You get c less than bx less than pi plus c. And then you divide by b. As long as b is positive, you don't have to switch the signs, so, assuming b is positive. So you'll have, but you will just solve this. Solve this. Those are your vertical asymptotes, this and this. And then once you find your two consecutive vertical asymptotes, we had, you identify, it's the same as tangent. You identify x-intercept halfway between them, midway between them. And then you find a point, you do a quarter of the way and 3/4 of the way. It's just switched, and then it's going to be A and minus A, respectively. This is, I should probably just be filling in the notes, but, and then you're going to graph one period, and then if you need more, then you're going to continue. So So the period of cotangent is pi. We've got, for cotangent, we've got vertical asymptotes at multiples of pi. You know, so, and the range, so yeah, so I just, basically this is the cotangent properties. Cotangent properties is right down here. The period is pi. The domain is all the real numbers except, it doesn't fit here, multiples of pi. And the range is all reals or minus infinity to infinity. And in this class, you can just write capital an R like that for all reals if you want. Vertical asymptotes at multiples of pi. An x-intercept occurs midway between each pair of consecutive asymptotes, and it's, let's see, 4, 6, even or odd function last one? Can't remember. Oh. 4, 5, 4, 5. Did you guys, are you looking at my children's notes? You got 4, 6?
I mean, it's on the computer too.
Oh, what? So, I forgot. Is it even or odd? I should look at it and see. It's an odd. Oh, yeah. So it's an odd function. I thought I couldn't think. It's an odd function with origin symmetry. And, you know, I had written this down, and it's A and negative A. It's switched. Okay? So, and then how to graph it, the directions for graphing it, that is, so the steps are very similar. Again, you just find 2 consecutive vertical asymptotes, but you change where they are at. Instead of minus pi over 2, you're using 0 and pi. and then you identify an x-intercept midway between them, and it's going the opposite way. Here's cotangent is going this way, and tangent's going this way. All right, and then, so that's cotangent, and we went through all of how to graph tangent. And the only other thing, and I'm not going to ask you to graph cosecant on the test, but you need to know some properties of cosecant. So let's put this up. Y equals cosecant x is 1 over sine x. You would graph sine x first, and then your x-intercept of sine will become the vertical asymptote of cosecant. Where sine equals 0, you're going to do 1 over 0, you're going to get vertical asymptote. So cosecant is not continuous. Okay, so that's kind of, and I'm not going to ask you to graph it, but you would graph sine x first and then cosecant. And here's, oh, I guess I'm showing you some other things. Okay, and the same thing with secant. How would you do secant? Y equals secant x is 1 over cosine x, which you should have memorized. And so the x-intercept of cosine will be the VAs of secant x. So it's, again, not continuous. Okay. Not continuous. Okay? That's pretty much what you need to know. The graphs of cosecant and secant are not as important. So instead of spending a whole class on those, we're going to go on to 4.7. So that's basically 4.6. The most important thing, graphing tangent, you will have to graph variations of tangent. Okay? Any questions? So just graphing, so we're on 4.7 because I don't know. I'm trying to get what I'm trying to do, guys, is I don't want you to have to study all spring break. Yes.
Can you put that back up there?
Sure. I don't want you to have to study all spring break. So, I don't want to move the test back to after spring break, really.
I mean, wouldn't be a problem.
We'll think about it. We'll see, but, you know, I don't think that'd be a fun way to spend your spring break. I'll be spending mine. I have tests in every class next week.
And we don't want to do that to you.
So I'll be spending my spring break grading tests, but so we'll see. But so that's why I'm skipping most of 4.6. So 4.7, I'll stop this and start.